Yep. My name is Michael Forey. In my free time, I work with high school students, and I teach them how to build electric racing vehicles. And one of the key components in a roadworthy race electric vehicle is that you're reliable and it runs every time you need it to. I'm going to teach you how to take the reliability that's necessary in building an electric vehicle and apply it to your Tableau server deployment.
I am Anup Kunjuraman. I'm a senior software engineering manager in Capital One. My resume is not as impressive as Michael's. I do not build electric cars, but I work mainly in the analytics and data engineering side at Capital One. I started my career building software for mobile phones. Not the iPhone or Android that you have. It's think a decade and a half back. It's where the Nokias and the Sony Ericsson rule the world, where the storage of a phone was not measured in MB or KB. It was in you can store 150 contacts, right? Yeah, it was a pleasure to write software for that, right? You get 120 KB and you need to work on that. From there, I jumped into writing software for set-top boxes. Yeah, another 150, 120 MB that you had to play with. But then I pivoted to, rather than writing software for set-top boxes, I jumped into analyzing data that is coming from all these million different set-top boxes and how to make sense out of that data. I really enjoyed that, and I continued to do that in Capital One in the data engineering side. 2 years back, I was asked to take on managing the infrastructure of our Tableau infrastructure, and one of the main project that was given to me was migrate everything that was there in our on-prem servers to AWS. I'm standing here and talking about it, so obviously we succeeded in doing that, and we are here to share what we learned in that journey. So, Tableau and Capital One. I'm guessing you all know a little bit about Capital One, right? You have seen the ads with Samuel Jackson asking the question, what's in your wallet? Most people know us as a credit card company. Most folks do not know that we are also big in other banking sectors. For example, we are the second largest automotive financer in US. People also don't know that we have a Guinness World Record that we won this year for the largest artificial intelligence training that we did. We had 848 kids from Dallas ISD participating in our AI bot camp, where we taught them how to write a bot that's AI enabled. We got that world record this year. Tableau and Capital One. So what's so special about Tableau in Capital One, right? Unlike most other companies where Tableau is mainly used as a reporting or analytical platform, one thing that differentiates Capital One is our high lean on the operational side of things. Tableau is used by everyone. Tableau is used everywhere in our company. In most other organizations, if Tableau goes down for a few hours, what is the impact? Not that much, right? You are not able to get to your scorecards, you are not able to get your CTQs on time. That's it. But not so in Capital One. In Capital One, a lot of operational processes depend on Tableau to be up and running all the time. If Tableau is not available for a few minutes or a few hours, the cost is going to be in millions for us, because a lot many team will be sitting idle, unable to do their job. A lot many workflows run through Tableau. So the necessity to have a highly resilient, highly available Tableau is very, very critical for us. Now, a little bit of a background on where we are right now compared to like 2 years back. In 2015, Capital One made a bold decision to go all in on cloud. We said that from that point on, all new applications that we are going to create will be on cloud 100% in AWS. And also, all existing applications that we had need to be re-engineered to run in cloud. Now, if you take a look at it, if you own the source code, if you own the architecture of a product, it's easy to re-architect it because you know about it. It's easy to package it and make it deployable in cloud. I'm not calling it a trivial thing, but it's something that you can actually manage. Now take a COTS project, something that is available as a package for you, like Tableau. When you think about Tableau, it's a bit difficult because you need to sort of re-architect something that you do not own the code for and somehow make it run in AWS. And we soon realized that the AWS templates and the templates that are available to us was not cutting it for us. It was not satisfying the high RTO, RPO, the resiliency factors that we were looking, the disaster recovery needs that we wanted from our platform. So we decided to go ahead and create our own reusable infrastructure as a code deployment strategy for Tableau that we started somewhere in 2017. I had Michael join me around that time, and we went ahead and got that implemented. Right now, we are 100% in our Tableau infrastructure that caters to most of the employees in Capital One. We are running it 100% in the cloud. We also have most of our data sources migrated over to the cloud. Now, we are here to talk about what we learned in that journey, hopefully it'll help you to know what you should think about, what pitfalls to avoid, and throw some spotlight on what most people do not tell you what you need to think about. Like after you get to cloud, what then? How do you run a well-managed Tableau infrastructure in cloud? So that's the whole point about today's talk. So today's agenda, we are going to mainly focus on a 5-point checklist that we created for all new Tableau deployments in AWS. Think of this as an equivalent to 12-factor app. If you're an application developer, I hope you're familiar with that 12-factor application, 12-factor app list. This is a condensed list, something similar to that created for Tableau. We are going to go through the key drivers for success here, the common mistakes that you are going to see here, and also once you deploy, after you have deployed it, what will be a good monitoring and managing Tableau strategies. Okay.
Thank you, Anup. So when you think about your Tableau deployment, you should look to have a deployment that meets these 5 criteria to maximize the value that Tableau has with the cloud. These 5 items are going to start off high level. In a couple of minutes, we're going to dive into the specifics of how we actually implement these at Capital One. So your deployment should have a change-controlled code base. This includes things like you should have infrastructure defined as code. You should have all of your binaries and executables and files stored in a change-controlled and a reliable, accessible environment. You want to have your infrastructure dependencies mapped out, lined up, so that you know where things are going and where they're coming from, and when something goes down, you can recover from that. You want to have environment isolation and also environment parity. So your QA environment is physically separate from your dev and your prod environment, but there's also the underlying code that you use is the same for this, for that, and the other, so that when you go and you migrate from here to there, you're not reinventing the wheel. You're not making overarching changes that could accidentally break what you're trying to deploy. You want to have disposable infrastructure, right? You have a server, you have Tableau, you're leveraging that, but if something goes down, you're not married to it, right? You're just borrowing it for the time, and when something goes away, you're really good at recovering. And then you also want to have a thoughtful design when you build out your plan. You want to know what your business customers expect in terms of how often are you going to restore from backups, what the amount of time, the latency that you have for those backups. And you want to build out a plan that helps meet those expectations with your customers while also minimizing the amount of manual interaction that you have with your deployment. The deployment that we use at Capital One gives us an advantage. If you go out on the open internet and you search for things like deploying Tableau quickly or effortlessly, or Tableau in the cloud, or name your favorite cloud provider or on-prem, you're going to find a lot of different options, right? I've surveyed a handful of those, and they're all pretty good at different things, but they all have different gaps, right? There's one famous cloud provider that I won't name that has a quick start for Tableau, right? And you go and you fill out these steps, and one of the first things is you've got 30 blanks that you fill in, and you type in information. I want my Tableau server to be this, and I'm going to get my security groups here, and so on and so forth, right? That's 30 opportunities for mistakes, right? As fine as that sounds, right? It still isn't hands-off or reliable or consistent, and it's not personalized, right? It's not necessarily what you want to do, and it's difficult to have that repeatable. In other situations, there are fast deployments where you have to already have the infrastructure and the files readily available, and then you can install Tableau, and it fits this very narrow corridor, but it doesn't do before and the after. So the deployment that we have that I'm going to show you at Capital One is flexible. It's well documented. It's organized. It's robust, and it's optimized. And when I say optimized, what I mean is before we deployed this, when we deployed our Tableau server, we had approximately 1,000 button clicks, right? Imagine 1,000 opportunities for mistakes. In any one of those button clicks that goes sideways, and you either start from the beginning or you spend hours trying to uncover and unravel something. We went from 1,000 button clicks to about 10 button clicks, right? Some of you people are going to measure the deployment effort in the amount of time it takes. That's fine, right? We reduce the amount of time it takes, right? But more importantly, I want you to look at the opportunities for errors, the button clicks, the manual intervention that's necessary, and how you can drive down your deployment to very nearly single-click installation. So I know y'all are coming here because you're probably Tableau admins or you're aspiring Tableau admins, and you've got an entire conference teaching you about Tableau and how awesome Tableau is. We at Capital One use Tableau. We use it on AWS, and so we're going to get into some technical AWS jargon. If you don't know anything about AWS, I want to make sure that you're brought up on some terms that we're going to use. So if you already know AWS, you can just check your email for the next couple of minutes, right? We have S3 buckets. S3 buckets are a glorified data file server, right? Like a hard drive, but more reliable. It stores data. We have EC2s. This is a computer that you rent that's in the cloud. Route 53, this is AWS's branded DNS server, right? So you have your URL. It points to a DNS server, to Route 53, and then that routes you to this particular load balancer, which is your server. Nothing phenomenal about that. A region in AWS is a large geographical collection of computer stuff. So the entire state of Virginia is a region. Mexico has a region, right? It is large. It contains a whole bunch of stuff. Inside of those regions are what's called availability zones. So in the Virginia region, you've got 6 different availability zones. You can deploy a typical server cluster that's spread out across multiple availability zones for some robustness, right? They're all really close to each other, but they're also a little bit distributed. And then we've got a CloudFormation template, which is a text document that describes your infrastructure, right? It's JSON or YAML. It's structured, a little bit more glorified, but that's what we're talking about there. I see some pictures. I'll pause and let y'all take notes digitally. All right, we're good. We're good. All right, so let's talk about specifics. This is a picture of the infrastructure that we have at Capital One. You can see flashing here that we have our main production server spread out across multiple availability zones, right? You want to spread them out across multiple availability zones so that it's resilient to minor fluctuations. We also have here a single staging node. Now this is right close to our production. This gives us an opportunity to do some testing, limited testing before they go into main production. You might envision this. Maybe you've got 7 different LOBs that you support. Each one of them has their own server, right? Different URL, right? Okay, so swap out this Tableau staging for LOB2, LOB3, LOB4. Now, if you think that I'm abandoning half the screen here, and that there's just going to be a bunch of notes, nope. Actually, we take all of this infrastructure in one region and we replicate it in our disaster recovery region. It looks exactly the same, but instead of being on this side of the country, it's on that side of the country. It's not on. It's always there. It's available to be turned on, so we're not spending money on it, right? And this is to help prepare us against wide-scale disasters. We're going to get to that in a little bit. Great. Thank you for the question. So we have our multi-regions in case there's, say, a hurricane on the eastern seaboard. We can go and jump over to our disaster recovery quickly. These load balancers are behind Route 53. So whenever we want to move over, we go into Route 53. We can adjust, say, instead of going here, you go there. Our customers are none the wiser. And then, of course, we've got cross-region replication. I think this might address your question. So whenever we have files that change in one S3 bucket, AWS automatically moves those changes over to a different S3 bucket. So two buckets, always on, always at the same time, that have the latest information ready to go. We use CloudWatch. We're storing so I'll get into that in more detail. But yes, our extracts are stored in our S3 buckets in addition to a lot of other things.
Why do you not split your production across 2 regions?
You can't do that. With one particular server, they have to be contained within one particular region. Tableau sends a lot of information back between the different nodes. And the way that AWS has their regions connected is it expects all one server to be inside of one region. The next best thing, it's an AWS.
I wouldn't say it's a limitation. It's just that it's not recommended in the sense that you need to open up a lot many ports for the inter-cluster communication, and that is not, we are not comfortable opening those ports outside for a VPC outside of that. So right with this setup, all of our inter-process communication ports are contained within the VPC. It's not available outside. So we took a look at different disaster recovery deployment strategies first. We first looked at an active deployment strategy where both the clusters are up and running in both the situation, or you have one cluster shared and split between different regions, things like that. But we finally landed on this because this works in the Tableau world. We really cannot run 2 clusters active at the same time because of things like extracts running simultaneously in both the regions, your subscriptions getting executed simultaneously in both the regions. So it's not recommended. It's best you have 2 regions, but one of the cluster is passive, one is active, and you have a switch to flip the regions.
Thank you, Anoop. We use CloudWatch to monitor KPIs and then send alerts to our admins. Now, this is approximately half of our infrastructure. This is our prod. I mentioned earlier you want your environments to be isolated from each other. We have an exact replica of this for QA. I say exact replica. We spin it up when necessary, right? It's easy enough for us to go and create all of this, so we don't actually have it on. We're not spending any information. Whenever we need to go in, we spin it up, we do what we need to do, we get out of there. So Tableau, as you know, is complex software. It's powerful. It gives you lots of features, lots of options and opportunities. With all of those options, you have opportunity to make mistakes, right? Yeah, you can customize it for you, or for you, or for you, or you can customize it for you. You fat finger something, and then suddenly it doesn't do what you're looking for it to do. We've tested out a variety of different ways to reliably deploy, to minimize the opportunities for mistakes, right? To reduce fat fingering and human intervention in making mistakes. And we have what we're presenting is our recommended deployment pattern to maximize the value of Tableau and also maximizing what AWS has to offer. We had a particular example a while back where we spent all day deploying a new cluster. We did lots of testing and regression to make sure that does this work, does that work, how are we doing this? Nighttime came and we're like, yeah, we're ready to go. We're going to switch over to the new server. We clicked a couple of buttons. We went to bed. And we got up the next morning, and our phones were ringing off the hook. Not literally, right? We don't use phones. We use Slack. But the point is that half of our users couldn't even log into our server because of one small change that we accidentally made. We didn't even realize in all the testing that we were doing, right, that this one small thing happened. So we jumped to, we went to resolve it. It didn't take very long for us to make the change and to turn back on. But for these half users, they weren't able to use Tableau for an entire day, right? I looked at the team and I'm like, we all did our best in this situation. We responded appropriately and quickly, but we can't do this again. We had roundtables and meetings. We made lists and did FMEAs and big picture charts. And we're like, all right, if we were going to do this all over from the beginning, right, scrap Tableau and have a whole new BI tool, what would we do so that this is not a problem? And we came up with a map on how to deploy Tableau on AWS that de-risks the opportunities for human beings to make very small clerical errors. So let's jump into that. At the root of what we do, we've got parameterized scripts, right? We have computers that send information back and forth, and we keep human beings out of it, right? Tableau is a rock-solid piece of software. It is great. AWS, solid. The biggest risk that you've got to your server is me or you or human beings, right? Once you get the human being, the human element out, it is a great combination. So we start off with a CloudFormation template. I'm going to go into the specifics of what we cram into the CloudFormation template, but the idea here is that there are minimum number of opportunities for people to go and say, this is what I'm doing, this is what I want, right? You don't have an opportunity to type in your security group that you want applied to this particular EC2. No, because you don't change your security groups every week or month or probably even year, right? So that's not an option, right? You can punch in things like the region that you're in or the environment, right? Maybe you've got LOB1, LOB2, LOB3. Okay, you don't type that in. No. You've got a drop-down box, and you pick, right? So you don't even have the opportunity to change a capitalization on LOB1. Is it capital L, lowercase l? No. So you have your CFT that kicks off your initial node. Now, y'all are all tab administrators, right? So you know that the difference between your initial node and your additional nodes or your worker nodes if you're pre-TSM, right? Your EC2 gets turned on, and you kick off some shell scripting. Your CFT kicks off your additional nodes. Now, I haven't mentioned how many additional nodes. That's not a parameter, right? In the parameter that you've got in your CFT, you say, this is the LOB that I want, this is the environment that I want, and the CFT knows, okay, I need one additional node, and I've got X additional nodes, right? You don't have the opportunity to say, I want 4 additional nodes this time, or maybe I want 12, or 3. No. You take that out of your hands and you put that into your script. Because it might not even be you that's kicking off the script, right? Once you get this going, you can delegate to somebody that doesn't even know Tableau that well, because they don't need to know Tableau that well. So all information, I had a question about S3 buckets. All information for us is stored in our S3 bucket, right? We are air-gapped. We don't reach out to the open internet to say, oh, we need the latest version of Tableau. We need the latest driver. We need this particular shell script. No. We store it all in an S3 bucket. If you guys don't like S3 buckets, that's fine. Find another repository that's reliable and available to store the information you need. Somebody came to me and they said, well, we store all of our script in GitHub. That's great. We do too. We don't pull from GitHub, right? Because my Tableau server is rock solid, and I need to be able to deploy anytime, day or night. And GitHub, at least in some institutions, has a history of going down with short notice for maintenance updates. Hey, that's cool, right? You run your GitHub server the way you want to, and I'm going to run my Tableau deployment the way I want to, and I'm not going to rely on you for business-critical stuff because your SLA says that you can go down without notice for 12 hours, and my SLA says that I've got to be up 99.9% of the time. So I'm going to rely on an S3 bucket that is consistent, and it's always there. So back to thoughtful design, make sure you rely on data sources that are actually going to be reliable enough for what you're doing. Now, the initial node will spin up. It will install various items. It'll install Tableau, and it'll push some information back to the S3 bucket. The most critical piece of information is it will generate what's called a node configuration file. You don't have to push that back to the S3 bucket. Push it somewhere that's, again, reliable and available for your additional nodes to pull it down, because they're going to need it in their shell scripting. At this point, the additional nodes and the initial node will start sending information back and forth to say, hey, I'm here and I'm ready to do something. Send me the topology information and start setting up your settings so that we can get going. And then the initial node, of course, will kick off a scripted routine that will start running backups that will be stored in a reliable location, like your S3 buckets. Last but not least, your CFT will kick off some CloudWatch alarms so that you are monitoring your infrastructure. We saw in this morning's keynote that Tableau is rolling out ways to monitor your infrastructure. It looks really cool. I'm totally excited about it. But if your infrastructure that's hosting your infrastructure monitoring goes down, then you don't know that it went down because it went down and it can't tell you. So make sure that you're monitoring your infrastructure with something else. AWS provides CloudWatch for something like that. I highly recommend you use it in addition to other tools. All right, so let's dive a little bit more into the CloudFormation template. This is where the human being goes to kick off everything that they're doing. We have a very limited number of manually assigned variables, right? The user can choose the region that they want to deploy in. They can choose whether it's a production or a test deployment or LOB1 or LOB2 or LOB3, and then optionally they can choose, they can set in a host URL, right? Now, I say optionally, if you're going to deploy something for LOB1, you've got the same URL, the same CNAME. You don't change that day over day or month over month. You don't really need this parameter, and you don't want it to be a parameter. But sometimes you want to have your production environment, and then right next to it, you're about to switch over to this other server, and you want to give it a different URL so that you can jump in and play around with it before making it live. So give yourself that parameter where you can punch that in optionally. Now, in your specific situation, you might want to have different parameters, right? Maybe you want to have different things for QA and prod and dev, and you want to switch those up a little bit. The emphasis right here is that you minimize the manually inputted things, right? You don't have things like your security group or your AMI or your S3 bucket name. No. You don't need to punch in your S3 bucket name because the CFT knows if this is where I'm deploying, right? Then this must be my account. This is the region. And then this must be the name of the S3 bucket that I'm using, right? Because you're smart enough to program that logic into the CFT, and the CFT figures that stuff out. And there's less opportunity for you guys or for your direct report or your delegate to make mistakes, right? And I hope maybe you can see a little bit far into the future that I'm hinting towards, but I'll spell it out clearly. What the end goal is here is that it's not you that's doing the work, right? It's somebody that either gets paid less or is split among lots of different things, or maybe even perhaps a computer is kicking this stuff off on a schedule in the future, right? Okay. So let's move forward with S3 buckets and what S3 buckets store. Now, we use S3 buckets to store everything. It's reliable, it's available, it allows for the flexibility to structure your folders in any way you want. This is the folder structure that we use at Capital One. We have a folder for shell scripts, right? Your EC2s are running shell scripts. They got to be stored somewhere. Put them here, right? Shell scripts for the installation, for configurations, for topology. All of that goes right here. And because it's an S3 bucket, it's version controlled, and you can see what exactly was run at a particular time by looking in the history.
I need to jump in here and say that we have version control enabled by default across all of our organizational buckets. So that's an advantage that we get out of the box. You may not be running the same thing, but if you are storing configuration in S3 bucket, it's always advised to turn versioning on so that you can always go back and check the different configurations that you use.
You got to store your drivers. Put them all in a folder for drivers. Don't reach out to the open internet. Maybe you want to rely on something like Artifactory to store some of this information, right? But the idea is that it's got to be reliable and consistent and available in a way that AWS commits that an S3 bucket can. Store all your binary files, right? Maybe you're testing. Maybe you're in Tableau 2019.3.5 and you want to upgrade to 2019.4.0, right? Okay, so store that binary right next to the other binary, right? Maybe you got a whole long list of the different binaries that you may or may not install, right? Keep them there. Maybe perhaps you want to install Tableau Desktop on your server just to do some testing around, right? Store that there. The idea here is that you're not reaching out to the open internet, right? You're not relying on some other third-party site to keep track of what version of the executable was available at this particular time. No. You bring all that. You own that, right? And you make sure that it's consistent. It's the same every single time, and that you are in charge of the availability. Store your CloudFormation templates. They got to be stored somewhere, right? You can pull them off your desktop. That's not too bad, right? Or you can store them in an S3 bucket and version control that, right? And then, of course, Tableau backup files. Your Tableau backup files are critical to your ability to recover, right? So put them in their own folder and then parameterize the name of them so that you can quickly reference them. This is the backup file for LOB1, right? This is the backup file for LOB2, and it was generated in this particular region. You're recovering in a different region, and you've got to be able to look for that specific file in that specific name. So make sure to name them in a way that makes sense for your ability to recover. And if you're considering about going into AWS, or if you're already there, you can also have lifetime rules to automatically delete older backups after a predefined amount of time, so that your S3 costs don't grow out of control. Your EC2s will run automated scripts, shell scripting, right? They'll receive parameters from your CloudFormation template. You want to limit the number of parameters that you pass through. I was talking to one gentleman, and he said, I like what you're talking about here, but I don't like CFTs. They're not available in my company. Okay, that's fine. You still want to have shell scripting to kick off the work that's about to come, because somebody has to do the work, right? It's either going to be a CFT, or it's going to be a human, or it's going to be some other automated thing, right? And you want to minimize the number of things that you got to pump in there. So make it simple on yourself, right? Put your work inside of a shell scripting. In ours, we have a handful of parameters. We have the S3 bucket, the node identifier, right? Is this the initial node, or the additional node, or is this LOB1 initial node, LOB2, LOB3, so on and so forth? And then optionally, the host URL. Now, I mentioned this is optional. If it's blank, you need to have logic in your code that says, okay, if I am here and doing this, then this must be what we're doing. There's a lot of fields that are calculated dynamically, right? One of them would be the host URL if it's blank. You're going to need the SAML file, or email configurations, backups, scheduling. I'm going to get to this in just a second, but you can turn scheduling off at the beginning and then turn it on a little bit later. You can move your email settings around, right, which is something you want to do if you're going to spin up for a test environment. You don't want to send with a response to your production server. You want to send it from the actual server. And then you want to download all files from the S3 bucket or S3 equivalent that's reliable and consistent to meet your commitments to your customers. Hold on your pictures just one second, and take your picture. Because your EC2s also upload information, like the backup file, and then the node configuration file gets passed around between all of your nodes so that everything can connect properly. Any pictures? Wonderful. Okay. Now, I know what you're thinking. Some of you are saying, hey, Michael, hold on a second. I love what you're talking about, but you can't actually expect me to click a couple of buttons in a CFT and then sit back, relax, drink a margarita, and know that my production server is going to get up and running. No. If anything else, like I'm accountable for this. I need to know what's going on. I need to get some billable hours. I need to test and do stuff. That's all right. I got you covered, right? So you bifurcate your script. You run everything that we just talked about, but with a couple of small changes. You activate Tableau as a trial license. You disable your subscriptions. You configure your server with a test URL. And you still restore Tableau from the latest backup. And then you stop, right? So at this point, you've got a server that's up and running. You've got all nodes. They've talked to each other. You've got the latest backup file. You've got the topology set. You've got your settings just the way you want them. And then you go off to maybe a third-party individual or your QA team, and you say, here's the URL for the test environment that I just spun up. Jump in, do all the QA testing that you're accustomed to do, go through your checklist, make sure that I didn't miss anything, and then maybe perhaps just wait until an appropriate time in the evening, weekend, 3-day weekend, when you can actually go through stage 2, right? And stage 2 is the latter part where you go in and you activate Tableau with the production license, you enable the subscriptions, you configure with the real URL, and then you restore Tableau from the repository, which is typically much faster than doing a full restore. and now you're live, right? And you legit have your server with the right URL, with the latest version of everything that you're running, ready for people to use.
You're talking about the host URL, are you referring to Route 53?
So in your pre-TSM, so after you get to TSM, there's a handful of variables that Tableau needs to know who it is in order to allow connection, right? So this is maybe your production URL is something like mytableau.com, right? And you spin up with mytesttableau.com, right? You've got to switch that over to mytableau.com so that it receives on mytableau.com. You got to go into your email settings to say I'm sending from mytableau.com. So when you click on that notification, it takes you to mytableau.com. And then there's a third spot at a minimum of where you want to switch that URL over.
So you do get at the Route 53 as well?
At the Route 53 points to a specific load balancer at any given time. You're gonna stick your new server underneath that same load balancer, so you don't need to make any changes. And here's a pro tip. Not included because y'all are my friends and you showed up to my session. I'm going to give you a little bonus fact. If you use ALBs, application load balancers, you assign your EC2s to a target group that are underneath the ALB. And if you have fun with the sticky session, you can actually have two different target groups underneath the same load balancer, your old server, your new server, and you can have anybody that's currently on your server pointing to the old one, and then when that session expires, they get routed to the new session automatically. And don't tell my customers this, but we've actually deployed a whole new server in the middle of the day and used sticky sessions. There was no downtime, and our customers had no idea that they were on an upgraded version of Tableau.
Can I hire you?
We come as a package, by the way.
You have a package. Yeah.
I meant both.
Yeah.
So
Yes.
old-timers here would probably know that what we are describing here is a way to do blue-green deployment. Right? You create two different stacks, and you have a way to systematically route traffic from one cluster to another cluster. You get the ability to test different versions simultaneously. You get the ability to do A/B testing. All those things are available if you structure your architecture, your deployment strategy like this.
Okay, so up next, we have CloudWatch with SNS topics. You are going to want to use CloudWatch. It's native to AWS to help monitor your infrastructure. And you can use AWS CloudWatch to monitor a wide variety of things. At a minimum, I would recommend you monitor your CPU usage, your network in and out, and then your EC2 status information. Some of you might know it by a different term. Status information. Is your EC2 on, right? Yes or no? It sounds pretty straightforward, pretty basic, but when the answer is no, you really, really want to know about that. And so you can use CloudWatch to help monitor that and then send all your favorite people an email when the answer is no. With SNS alerts, you can notify a wide variety of people. You can notify your admins. You can send text messages. You can even send notifications to third-party messaging systems. We'll dive into this a little bit more, but Datadogs or Prometheus or so on and so forth, right? It doesn't have to be just confined to an email to me. All right, so we've talked a lot about great things to do with Tableau in AWS. Let's talk a little bit about things that you should not do. Things to avoid. So we're running Windows on Tableau, and one of the fun facts about that is you've got to log in to TSM on your server, and after a couple of minutes, I don't know how long, it logs you out, and you got to log back in. Now, if you are deploying Tableau by going in and saying, oh, this setting and then this setting and install and blah, 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 every so often you'll be like, oh, I got to log in. TSM login, no big deal. If you script this stuff with a computer, then your script is going to be running through, and then you're going to get halfway through and you're going to need to log back in. So my advice to you, just throw in the TSM login command every so often, right? You do some work, let's log in again. You do some more work, let's log in again, right? So that you don't get this log out error. You want to log error codes. You want to watch out with your CFTs, right? They're very sensitive to formatting. So when you go and you play around in your CFT, right, make a bunch of small changes, right, which is just good advice whenever you work with code. Make some changes, test it. When you go with your CFTs, make small changes, and then test it. Install drivers last. The most important thing about your server deployment is that Tableau is installed. Drivers, I suggest you put those at the very end because you don't need to restart your Tableau server if something goes haywire with your drivers. So just push those back to the end. Long polling times. Throughout your script, you're going to need to do things like go on, have script running on your additional nodes and say, if this node configuration file is ready, then go forward. If it's not ready, then wait X minutes and then try again and do that again and do that again and do that. Okay, now it's ready. Now I'm going to go through. Give yourself plenty of time. Right? In early iterations of the code we had, it would wait for 10 or 15 minutes for the node configuration file, and if it didn't receive it, then it would just exit out and not do anything. And that worked really great when we were testing. And then when we started to roll out to actually deploy, it turns out that this other thing just took a little bit longer, and I needed more than 15 minutes for that polling. So just give yourself like boatloads of time. At least early on, because it's not going to cost you anything if your script's just running around in circles. Coordination service cleanup. When you deploy multiple nodes, you've got a coordination service that makes sure that all your nodes are in unison. You've got setting up the coordination service, which is kind of straightforward, and then you've got to clean up the old one, which is not as straightforward as it should be. So I would encourage you to set time aside to play around with that particular step, right? In one particular solution, you can do a TSM status, right, to see, okay, is it ready, is it ready, is it ready? And when the answer is yes, then you go forward. Or you can hard code in some wait time to say, okay, I just deployed the new coordination, I'm going to wait X amount of time, and then I'm going to clean up the old one, right? Play around with those variables, but anticipate that's going to be an issue if you're just going into this cold. Okay, we're going to get into some dry stuff. I'm not going to show you the actual code because I think that would just be a little too dry, but this, hold your pictures for a second, yeah. This is the recommended order of installation. I promise it'll get better, right? That I recommend that you deploy your settings, right? I'm not reading this. You can take a picture now. We played around with a lot of different order of applying the settings, right? Different order introduced different errors, different problems or wait times, right? This isn't the only way to deploy your settings when you install your Tableau server. But I will say that if you follow an order like this, that it's going to be pretty fast, right? It's not as fast as it could be, right? There's some opportunity for improvement, right? It's going to be really fast, and you're not going to have code stepping on each other, right? We made one small change while we were testing this out. We're like, oh, I want to do this a little bit earlier because it'll make this other thing, and then something wasn't ready, and the whole thing went kaput. And we wasted a whole day. So I would recommend starting off with this order and then play around with it. Have some fun. Okay, so we want to make sure that the time that it takes to deploy is as small as possible. There are some things that take time that we just can't get around, right? If it takes you 5 hours to restore from a backup, I don't have any tips for you, right? Like, if it takes 5 hours, it takes 5 hours plus, the amount of time it takes to do other stuff. So I'm going to talk about other stuff. One, restarting Tableau takes a long time, right? It takes 20 minutes to turn it off, 20 minutes to turn it back on, right? You want to change your email setting, right? Okay, TSM stop, 20 minutes later, change the email, TSM start, and that's 40 minutes of your life, right? So if you've got your install script and you do a couple of changes, apply, start, stop, couple changes, apply, start, stop, right? It really adds up. So when you install Tableau, right from the get-go, there is a setting where you can do silent installer, do not start Tableau, because if you let it start, you're going to install, you're going to wait for 20 minutes for it to start, and then the next thing you're going to do is TSM stop. Okay, that's 40 minutes of your script. So just don't even start. Look out for changes that do require a restart and try and minimize them, right? Like applying changes, granting repository access. That was a fun gotcha, right? We've got a live Tableau server, and we're like, oh, we forgot to turn on repository access. I'll just go in and do it and apply later. Whoops, our server's down for 40 minutes in the middle of the day because we decided to do that. Restoring from a backup, of course, you got to stop. You got to restore from the backup. You got to start again, right? Look for opportunities to reduce the size of your backup. In many cases, right, there's not a lot you can do about the size of your backup. And I'm sorry. Adding and removing nodes still require a restart, right? We really like it if we could add or remove nodes without having to restart the whole server, but this is the way life is today. Changing your cluster controller, right? If you've got your cluster controller monitoring nodes 1, 2, and 3, and you want to do nodes 1, 2, and 4, or you just want to start, right, your brand new install, and you want to install, create your cluster controller, you got to stop, you got to apply, and then you got to start again. If you want to move your file store, you got to. I don't even know the right steps to move your file store because I tried it. It was a train wreck, and I don't do it. But know that it's more effort than you think it would be unless you've actually researched it. And then it takes exactly as much time as you think it would be. And if you can figure out a solid way of moving your file store, give me a call. Yeah. Okay, so, take a picture. Take a picture. This is it. I don't move either of them. Personally, I don't move either of them. If you want me to update this slide with whatever experience you've gleaned, let me know. All right, so we've done a lot of jibber jabber, a lot of talk. Let's watch a video of all this in action. It's going to loop, so if you miss something, don't worry, it'll be back in about a minute. Okay, so here we go. We are at the CFT screen. We chose our CloudFormation template. Now we're punching in the name of the stack that we want to create. This isn't used anywhere except for our own personal reference. We scroll down. There's a lot of fields here. They're not used. I just haven't gotten around to getting rid of them. We choose the environment. We type in the name. Oh, there it is. We've got a couple of different options there for which server we're going to choose. Oh, and I made a mistake. All right, let's take out that space. You click Next. Click Next. Who's counting the button clicks? Oh, box. Bam, go. And there it is. Wasn't that fun? Who wants to see that again? Yeah? Let's see. Yeah, there it is.
What's the actual processing time that it takes to go through the script?
It takes us, we give it about 2 hours. It takes less, but we give it about 2 hours. The bulk of that time, man, I measured it out. The time looks somewhere along the lines of 15 minutes to install Tableau. Oh, yeah. 8 minutes to spin up our EC2s, a couple minutes to download files. Install Tableau is 15. A bunch of configuration settings that take less than a minute. Restart is, again, just apply is 10. Restoring from a backup takes as long as it takes, right? Stop, start. And that is about 50 minutes. And then you do that again for applying topology on the additional nodes.
What's your restart time?
From end to end, 2 hours. Less than 2 hours.
Including the backup restore?
Yeah. Yeah, we did it in a record 1 hour 15.
We got it now. Our backup is 12.5 hours.
All right. Yeah. Yeah.
Well, we just went to that version of that, so we'll check the no compression backup. Yeah, 2 hours must be the magic number, though, because I have an almost identical deployment, and it's 2 hours to get everything running, but minus the backup.
Mm-hmm.
So we've gone through it. It's 2 hours.
Mm-hmm.
To finish the scripts.
Yeah, and I would say that the additional time that those 2 hours are coming from starting Tableau. Yeah.
All right, we got folks from Tableau over here. Chris, you got a customer empathy. Tableau restore, the backup restore is taking too long.
Yes. They have the no compression backup option as 2019.4. It's supposed to make it 3 times faster and 2 times larger.
All right.
About the effort to learn the cloud formation scripting and to really get that to where it was doing what you wanted to do. How long did that take you? What was the learning curve?
I would say it took us about 2 years to the state we are in right now. We didn't start from scratch. We used available templates as a learning pad and then build on top of that. I would say we are not there yet. We are still building on top of this one. All right. So, few more important things before we wind up this session. So far, we saw how to get this deployed into production. Then what happens? Now you have a cluster running in prod. All your users are heavily using this. The last thing that you want is some of your users to come back and tell you that, hey, your cluster is not working. The URL's down, right? So you should be the first person to know if your cluster is healthy, if your cluster is unhealthy. You or your L2 team or your SRE team, whatever structure is in your organization. Things are a lot different when you come to the cloud world compared to the on-prem world. It's not a matter when your EC2, it's not a matter when or if your EC2 is going to go down, it's just a matter of when it's going to go down, right? It will go down at some point or the other. Do you have enough tooling to catch that event and automatically mitigate that if possible? Now, this is a very opinionated slide. This is the stack that we use in Capital One to monitor. You do not have to use any of this, but the takeaway that you should take from this slide is that you need to have a monitoring strategy in place. And you need to think of that when you're building your infrastructure as well. Now, we use CloudWatch, So we use CloudWatch heavily for monitoring our infrastructure. We get a lot of out-of-box metrics coming from CloudWatch that we have configured as alerts. I just want to pause a bit and say, what constitutes as an alert? What do you think constitutes as an alert? Does every event becomes an alert to you? If everything is an alert, then nothing is an alert because nobody's going to act on it, right? So you need to carefully pick and choose what constitutes an alert in your world and make sure that humans are pinged only when there is an action to be taken. Otherwise, those are alerts that are good to know. That's it, right? So a node going down that impacts your cluster, yes, you probably need to know. Definitely have a black box URL probbing in there, right? I mean, the CloudWatch slide, we do not get black box URL prob in CloudWatch. We heavily use Prometheus for that. Prometheus gives us a bunch more metrics than CloudWatch. We heavily use the node exporter from Prometheus. Prometheus as the time series database combined with Grafana as the front end is amazing for us to actually know inside out about our cluster. Coming back to the point, have a clear idea about what all metrics actually constitute an alert and only send those alerts to your paging system. Hopefully you have a paging system that lets the on-call people know that there is a problem that somebody needs to act on. We in Capital One use PagerDuty. It lets us set up rotation policies, It lets us have multiple teams for monitoring our infrastructure. It gives us an idea about who is on call on this exact time. If they are not available, it gets escalated to their manager and to their manager, things like that, which is working perfectly for us. The key takeaway is have something similar to this on your side as well. Now, something on the managing side. This is all we learned the hard way. Once you have things in production, once the users start to use this, how do you make sure that things are healthy and happy, right? You definitely need to have a backup in place. I'm pretty sure almost all of you have a backup in place. But how many of you can confidently say that your backups are healthy? Like the backup that happened today morning is healthy or not? Good. See, the end is you need to know that. You need to have a very good confidence that your backups are healthy. We all know about horror stories where folks thought that their backups are good, and when they tried to restore it, it was all corrupted, right? How do you mitigate that? We heavily rely on war games to do that. We have a playbook of disaster recovery. It's a well-documented, it's a live document. It's simple enough for even a junior developer who just joined my team to read and understand and execute. It's on a very detailed level. They do not need to know anything about Tableau. They do not need to know anything about AWS. They probably just have to follow steps and get things into motion. So it sort of explains how to do a disaster recovery, how to bring up another region, how to move your backups over, how to restore it, how to bring up the servers, how to make sure that you are healthy. And again, make sure that even in the new region, you have your backups running fine, you have your reporting, monitoring, everything fine on that region as well. So have a live document that, and keep on exercising on that. You need to refine that document. You need to do that war game again and again and again until your associate, your engineers can actually do that in their night, in their sleep, All right, the last thing. This is again something that we learned from our experience, something that has been working fine for us in Capital One. It's an opinionated slide. You do not have to follow this. So far, we have two clusters, one called as pre-prod or the staging server, where it's exposed only to publishers, not to end users. Publishers are supposed to publish their reports first into the staging server. They need to meet our rigorous SLAs before it can be automatically moved to the production server. So we are not talking about different sites. We are talking about different infrastructure as a whole. We do not want a troublesome report or a workbook deployed into the production impacting other users. So we have segregated that on an infrastructure level. Our SLAs are something like your extract size cannot be more than a GB. Your extract cannot run more than X minutes. Your site, your dashboard should be up and viewable within 5 seconds. The SLAs on your side, your org, will be completely different. We have a strict control on how many users we have. Are they misusing our resources? Are they just creating dashboards that nobody else is using? We have monitoring on all those and automatic cleaning up of unused users, unused workbooks, things like that, which I believe somehow helps us to reduce the backup size tremendously. We also have an auto delete. Like if let's say that an associate left Capital One, the next day we have an automatic batch job that removes those users and their associated things from our servers. We remove the user and then move if they are a publisher in some of the reports, the publishing authority moves to their manager. We are using AD for that, yes. Upcoming development.
Yeah, we're out of time. Okay, so this slide is supposed to talk about the upcoming development that we have. Now, some of y'all have watches, and you'll notice that we are past our time. So take a picture, write down in your little notebook that we have upcoming development, and it looks like this. And I've been asked to ask you to fill out the change back for you. Yeah, I've been asked to ask you to fill out the survey. Personally, I don't really care if you've got feedback. Feel free to write that on the back of a $20 bill, and I will consider it in due time. So you are dismissed. No more pictures. There's the final slide.